Hello everybody, welcome. This is paper 1 from May 2022 and this is time zone 1. So I think this is actually quite a challenging paper. First question is a 5-mark question. The front view of a doghouse is made up of a square with an isosceles triangle on top. The doghouse is 1.35 meters high and 0.9 meters wide and sits on a square base. The top of the rectangular surfaces of the roof of the doghouse are to be painted. Find the area to be painted. Okay. So 5-mark question, no subparts or anything like that. What are they asking us to do in this case? In the end, we want to find the area to be painted, but only of these rectangular surfaces on the top of the doghouse. So in this case, we're not asking for the whole doghouse or even this triangular part at the top. We're just asked to find the area of these rectangular faces here. This is the only part that is going to be painted. So not this, nothing else except for these rectangular surfaces at the top. This is the only part that is going to be painted, the top of these rectangular surfaces on the roof. Okay. So also a good idea, I think, when approaching a geometry problem is to mark up and sketch on the diagram as much as possible. The IB will rarely give information that is not essential or information that is like deliberately to trip you up. Not to say that it's impossible, but often the case that if information is presented, it's relevant and you can make use of it. Just the questions themselves, often they're presented in a very short way and condensed with a lot of information. So let's see what we can do here and sketch any information. Any useful information on the diagram. Okay, so first off, they're telling us the front view of the doghouse is made up of a square, and then it has an isosceles triangle. So the front view is this portion here where we're looking at the doghouse, and they're telling us it's a square. And if it's a square, that means all of the dimensions of this doghouse are the same. So length, width, height, base, all of that is going to be the same. So that means that this right here is also equal to 0.9, of course, and more importantly, this height is also equal to 0.9 if the front view is a square. It's also telling us that there's an isosceles triangle on top. So an isosceles triangle, hopefully that'll recognize, not good enough, I'll just sketch it. An isosceles triangle, remember, has two side lengths that are equivalent, and then it also has two equal angles. For this question in particular, it's going to be important to recognize that we have, I guess, two equal side lengths for this isosceles triangle. So what does that mean? We know that these two are the same. And then the last piece of information that's actually pretty important for an isosceles triangle is, since we have two equal side lengths, that is to say, let me use this, let's say this and this are equal, and we have some symmetry, this angle and this angle are equal, we can divide our triangle, our isosceles triangle, exactly in half. And if we drop what's called an altitude, if we drop a line right from the highest point down to the base, it forms a right triangle. So we have two right triangles that are a mirror reflection of one another. So that's going to be important here as well. So if we drop this angle right here, or this perpendicular, I suppose, this line from the highest point to the base, we also have a right angle here. Okay, so there's a fair bit of information presented here. Another way to possibly work this out, just thinking about it, is if we know we just want to find this rectangular surface on top, we can say, okay, well, what would we need to find out this rectangular surface? Well, the area of any rectangle is just length times width. So we know that the length, given that this doghouse is on a square base, we know that this is 0.9, and this itself would be equal to 0.9. So we have the length. All we just need to find is I suppose, what we could say is the width of this rectangle, and then we would be good. And I think that's just about it. So this width itself corresponds to this W right here, and this W this width right here. We don't yet know it, but we know it's part of a right angle triangle. And then some things should probably be kind of moving around, and you say, okay, well, it's part of a right angle triangle. That suggests either our trig functions or maybe even better, Pythagorean theorem. So we need to find this w, that's the missing piece, then we can multiply it by 0.9. How do we find this, and then how do we find this? Okay, so we know that the total height of this doghouse is 1.35, and they also told us that the front view of the doghouse is a square. So that means this is 0.9, this is 0.9, and this as well, right here, is equal to 0.9. So if we know if the total height is equal to 1.35, and we know, for example, that this height of the doghouse, just up to this portion right here, is 0.9, the question becomes, okay, well, how much further would we need to go if we wanted to reach our equivalent height of going right up to the tip? You know, base to tip is 1.35, this is 0.9, and so that this height, this h, must be the missing piece, essentially. So, what do we have? We have, and given a 5-mark question, we'd probably want to put this in. The height of this rectangular portion, sorry, the triangular portion, is going to be the missing piece that we need to fill in. So 1.35 minus 0.9, and that would give us 0.45. And if we could call it h, I suppose we can. I'm going to move this to the side. It might be useful again, but I'll leave that for now. Okay, so there's our height right here, 0.45, and we can write that in. This is 0.45. So we have a right angle triangle. We know one side length. Let's go ahead and find this side length right here. And if we do, then we know we can apply our Pythagorean theorem, because we have two side lengths in a right angle triangle. This one isn't too bad. We know this whole base is 0.9, and so if it's 0.9 and we know our isosceles triangle divides this up into two equal sections, so here's one section, here's another section, we know that this itself must be 0.45, and this itself must also be 0.45, because 0.9 divided by 2 is 0.45. So 0.45. So this is also the base of this portion of our rectangular triangle. Okay, so we've got this rectangular triangle, this right angle triangle, and we know that this is 0.45 and this is 0.45. Now we want to find w. Pythagorean theorem is something that's not given in the formula booklet, but we know that for a right angle triangle we have a squared plus b squared equals c squared. So a, b, c, right angle triangle, we know that a squared plus b squared is equal to c squared. So the sum of the squares of the smaller side lengths equal the square of the larger side length of our triangle. So what do we know? We know that 0.45 squared plus 0.45 squared is equal to, in this case, w squared. So we can actually go ahead and end solve that if you want. That would work. We can rearrange this as well and take the square root of both sides. And so if we do, we'll have w is equal to the square root of all of this business. 0.45 squared plus 0.45 squared. That should give us the width of this rectangular surface on the top of this doghouse. So 0.45, I'm going to work this out on the calculator that I have beside me. 0.45 squared, and then we want to take the square root of that. And that's going to give us a value of w of 0.636396. So since we're not actually finished this question yet, I'm going to save a lot of digits. I'm not going to just keep 3 sig figs. I'm going to save a few extra. In the end, we're going to round it to 3 sig figs, so probably 4 or 5 should probably be okay. So there's w, the width. last portion of this question, we know that the area itself, the area here, area of a rectangle is given by length times width. So let's go ahead and work that out. The length we know is equal to 0.9, and the width itself is equal to, and I'm going to save a lot of these digits, 636396. And again, working out on the calculator that I have beside me, I'm going to work this out. 0.9 times 0.636396. And this gives us a value of 0.5728. And of course that's just one of the faces. There's also one on the other side here. So we're going to multiply that by 2. So let's take 0.5728 and multiply it by 2. 0.5728 times 2, and this should give us, so let's call this total area. This should give us a value of 1.15. And then if we wanted to, we could write meters squared. Okay, that looks good. Okay, so I think for this question, maybe some of the challenge comes in interpreting what it's asking and a close reading. So not only in terms of marking this up, but already from the beginning, recognizing that it's just this rectangular surface, not the whole doghouse, but just these rectangular surfaces. Then asking, okay, well, what do we need to find it? We already have this base right here, or this length, but we don't have this W, or the width, the slant height essentially. But we do have the total height, we do have 0.9, which again, we need to find, given that this is a square. And then lastly, if this is 1.35, this is 0.9, we have to travel a little distance more, 0.45. That corresponds to this. Again, we have an isosceles triangle, isosceles dropping in altitude, some line from the highest point down to the base, divides it exactly 2. So we know that this height is 0.5. This 0.9 is divided into 2. It's a right angle triangle. We find W, and then we've got our area. So yeah, fair bit going on. Sometimes with a 5-mark question without scaffolding, it's extra challenging because there's so many different paths. But there it is. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.